Hi everybody, my name is Anurag Gorkar and today along with my friends Yogesh Kulkarni and Pranav Patil, I am here to present our project CoviCare, a secure COVID-19 vitals diagnosis and disease identification application. This project was done under the guidance of Professor Sarang Joshi at Pune Institute of Computer Technology.
For this project, our aim was to create a single mobile application and a smart device for medical professionals and non-medical professionals alike. This smart vitals collection device allows the user to record their vital signature, namely body temperature, heart rate, and blood oxygen levels. It also has an onboard microphone to record your cough sound and analyze it for COVID-19 detection. This device also provides live vital streaming to our mobile application so that hospitals can keep a tab of their patients' vitals in real time. Now we will have a look at the block diagram of our project. Our project comprises of two main components. First, Smart Vitals Collection Device, and second, Smartphone Application. The Smart Vitals Collection Device is an embedded device with a pulse oximeter, a temperature sensor, and a microphone. These are used to collect the user's vital signatures through an easy-to-use GUI application. These vitals are then encrypted using AES by a dynamically generated secret key and displayed as a QR code. The user can import these vitals data into our CoviCare application by scanning this QR code. The smartphone application has 5 main components: vitals diagnosis, COVID-19 identification, mental health evaluator, cough sound classification, and infection mask segmentation. First, vitals diagnosis. The imported vitals are stored locally on the mobile device. We analyze these vitals using a rule-based algorithm as defined by WHO to generate a susceptibility score towards COVID-19. The user can also view their vitals over a particular period of time, say over a week, month, or a year, to gain an insight into how their vitals vary over time. The next component is COVID-19 identification using CT scans. Doctors or non-medical practitioners will be able to select an image of their chest CT scans through our application and then run a CNN model on it to predict whether the user has COVID-19 or not. The third component is a mental health evaluator, which uses a predefined set of questions based on the user's answers. Our ML model assigns corresponding weights to the responses and determines whether the user needs medical attention for mental health treatment or not. This component is aimed towards employers so that they can ensure their employees of their organizations are mentally healthy during these challenging times of a pandemic. The fourth component is a cough sound analyzer, which uses a raw cough sound recording to determine whether the user has COVID-19 or not. We will have a look at the architecture and working of this module further in our project. The last module is an image segmentation algorithm, which utilizes a UNet model to determine which parts of the chest CT scan are infected. This is especially useful for doctors in easier treatment. Now, we will have a look at the live demonstration of our project. For the first part of our demonstration, we will introduce you to our CoviCare application. This is an Android application written in Java. Now we will log in to CoviCare. Now I am entering my email ID and my password. Now we click on login. So CoviCare tells me there is no user corresponding to this identifier. So we'll need to sign up using these credentials. Now we enter our sign-in details. I will enter my full name first. Now I will enter my email ID. Now I will enter a dummy password. Now we go to personal details. Now I will enter my personal details. Now we go to contact details. We select our country code and we enter our phone number. Now we will sign up to CoviCare. CoviCare tells us that it has sent us an verification email. So I will just verify my email in a jiffy. Now that I have verified my email, we will log in to our CoviCare application. So now the CoviCare application will ask us for certain permissions. So we allow these permissions. This is the home screen of our application. Now for the second part of our demonstration, we will have a look at the GUI application running on the Smart Vitals collection device. This application is designed using PyQt5. It is currently running on a 3.5-inch TFT touchscreen. This application has been designed to be touch-friendly so that the user will be able to access its features easily. Now we will enter our application. This application has three main features on the home screen. First, record vitals, second, monitor vitals, and third, view vitals. Record vitals allows the user to capture their vitals one time and share those via a QR code to their CoviCare mobile application that you can see on the right. Monitor vitals allows the user to stream their vitals live to their CoviCare app. And view vitals allows the user to view their previously recorded one-time vitals on the Raspberry Pi device, that is, the Smart Vitals collection device. Now we will have a look at the Record Vitals component. On this screen, I will press this button and capture my body temperature. In order to get the body temperature, we are using an MLX 90614 non-contact IR temperature sensor. So I'll click this button and register my body temperature. My current body temperature is 33.23 degrees Celsius. Now we measure our pulse using our pulse oximeter. We take the heart rate and blood oxygen levels. I will press this button and capture my vitals. I have initiated our sensor. The sensor that we are using for this is a Max 30102 pulse oximeter. We are calculating these values for a period of 30 seconds to ensure accurate vitals data. So my current heartbeat is 98.73 and my oxygen saturation level is 98.25%. Now on this screen, I will click this button and record my cough sound into the microphone connected to our Smart Vitals collection device. This cough sound has been recorded as a WAV file and we generate a spectrogram using this cough sound recorder. This spectrogram is analyzed using our machine learning model in order to predict whether our cough sound is susceptible to COVID-19 or not. Now, these recorded vitals can be shared to your CoviCare mobile application via a QR code. This is the QR code that helps us to capture our vitals to our CoviCare mobile app. This QR code is encrypted using AES and uses a dynamically generated secret key. This is to ensure the security of your vitals. It can only be decrypted through our mobile application. Now, as you can see on the screen on the right, I will scan this QR code and import my vitals. Thus, we have successfully imported our vitals. On this screen, that is the vitals history screen, you can see the weekly, monthly and yearly trend of your vitals collected. Now, for the next part in our demonstration, we will have a look at the continuous monitor vitals feature of our CoviCare app. On this screen, we will generate a QR code which shares to us the URL at which the vitals are being streamed by our vitals collection device. This QR code is also encrypted. Now, I will select the Monitor Vitals feature on our smartphone application to scan this QR and continuously monitor my vitals data. I will place my fingers on both the sensors in order to do so. As you can see, we are monitoring our vitals continuously. This feature can be useful in hospitals in order to keep a continuous tab on the patient's health. On the home screen of the CoviCare application running on the Smart Vitals Collection device, the user can view their previously recorded vitals. These vitals are stored locally on the device using a SQLite database. So these are the previously recorded vitals of the user. These are the vitals that we recorded previously in this video. Now that we have recorded our vitals for one time that are locally stored on the mobile application and also streamed those vitals continuously to our mobile phone, we will have a look at the other features that we provide in our CoviCare mobile app. As you can see on the screen on the right, I have logged in to our CoviCare application. Now I will go to Added Groups. This screen shows us that we do not have any groups created yet. The feature that we provide on this screen is, say, if you want to monitor vitals for multiple patients at a single time, then one can create a group. I will create a new group and name it Family Group, as my aim is to monitor and store the vitals for all my family members. Now we add a description for the family group. Now we add this family group. Now I will enter this family group. Inside this family group, we can have a look at the description, the date at which the group was created, and the number of users. Under users, we have two different categories: online users and local users. Online users are those who have logged into our CoviCare application and have signed up with their valid credentials. Local users are those who have not logged in to our CoviCare application. One use case for those might be young children, wherein those do not have valid credentials to sign up to CoviCare. So, in order to monitor their vitals, we create a local user. You can select among an existing local user or create a new local user. Now, we will create a new local user. I will enter their name, their gender, and their date of birth. The user has been successfully added. Now you can see there is one local user and 0 online users. Now we will add a new online user. To add a new online user, you can either enter their credentials that they have used to sign up to CoviCare or scan their QR code. On the left, I have logged in as a different user and will show the QR code to add the user. I will click on this Add User QR Code button. Now, through my mobile application on the right, I will scan this QR code and add this user. Now we are adding the user, and the user has been successfully added to the group. Now we can record the vitals for this particular user. So currently this user does not have any current data. We can press this plus button and scan the QR code that we have generated earlier for one-time vitals data collection. This user feature can also be used by hospitals in order to organize their patients into multiple rooms and monitor their vitals simultaneously using a simple and easy to use single mobile application. The user can also see on which groups they have been added. So, on the left, I will navigate to the groups added to screen in order to view the groups that I have been currently added to. So this is the family group that was created by Archana and I have been added to this group. Now we will have a look at the mental health evaluator component of our CoviCare smartphone application. We have made use of an open source dataset for building a model. This dataset is from a survey which was used to collect employees' responses towards a series of questions revolving around mental health at the tech workplace. Now I will click on the mental health evaluator option. From this dataset, 8 feature columns were utilized for building an artificial neural network. These features are defined as follows: age, gender, benefits, care options, anonymity, family history, leave, and work interfer. These features are fed to a model which is trained using TensorFlow, including callbacks such as early stopping and reduce LR on plateau. Now we will enter the answers to these questions. I will select my options accordingly. The trained model is converted into a TF-Lite format for easy deployment on our smartphone application. The model size is only 55 KB. Now, as you can see on this screen, my score is assigned to be 0.13 and it reports that I have a normal mental health and do not require any medical consultation. Now we will have a look at the CT scan module of our smartphone CoviCare application. We designed a custom convolutional neural network model in order to determine whether the user has COVID-19 or not based on their chest CT scans. This model was trained on a dataset of 3021 images and validated on 1295 images. The model was trained using TensorFlow, including callbacks such as early stopping and reduce LR on plateau. The model is compiled by setting the optimizer as Adam and loss function as binary cross entropy. The detailed results are mentioned in the PPT further. The trained model is then converted into a .tf-lite format for easy deployment on the smartphone. The final model size is 11.4 MB. Now we will continue with the demonstration. So on the home screen, you have the option to pick an existing CT scan image or capture a new image. I will click on the pick image option. I will select an image. So our model has given us that the probability that this image has COVID-19 is 0.3, hence it indicates it as negative. Now we will look at the capture image functionality. Now I will capture an image. We have the option to crop this image as required. I will rotate this image and get the inference. This image is being reported of having 0.87 probability of having COVID-19, hence it is reported as positive. So this was the demonstration of our CoviCare project. Thank you all for your time.
For detailed explanation about each module, refer to the link in the description. Thank you.